Did Herman ask you to report it?
Somebody did. I think it was Alex. Alex texted me. And she said they're opening a new HEB and she had to work. They wouldn't let her out of it.
HEB open today?
Yeah, the new HEB on North Park. I don't know. All right, 9.6. And that's going to take us to page 653. Did y'all get that? Page 653. And this section is on solving exponential and logarithmic equations. Solving exponential and logarithmic equations. And we're going to start with problem number 7. And I know how much you guys like to use your Casio. Believe me, I understand if there's something the calculator will do, I know you like to push the button. So, I'm going to teach how to solve this particular equation using 2 different methods, okay? Now, can you tell me, is this equation exponential or logarithmic? Right? Duh, it doesn't have a log in it, does it? And so it's exponential, also because it has an exponent. And so this is going to be solving an exponential equation. The first method that we're going to cover is called the method of common bases. Do y'all want to write that down? This technique that I'm about to demonstrate, it's called the method of common bases. And so here's how it works. Is it obvious on the left that 5 is the base? Right? Because a base is something that has a power. So on this side, we see 5 is the base. So on the right-hand side, I'm going to try to convert 125 into 5 to some power, so that this has a base of 5 also. So we're going to put a question mark. 5 to the what power is 125? Third. Everybody see what I just did? And now, do the 2 sides have the same base? Okay, so therefore, where we get the name from, the method of common bases, we're going to have the same base. And I think at one point in this class I said if the bases match, they cancel. So if the bases match, they cancel. And we're left with 4x minus 7 equals 3. And then you can solve from there. Should be a piece of cake from there. Right? Move the 7 over. And divide by 4. Move the 7. Divide by 4. And I would like that as a reduced fraction. Five halves? Anybody have any questions? Did that seem to be pretty easy? That's not terribly difficult. However, there is a downside to that technique. Okay, here's the downside. Is it always possible to get those bases to match? No, because if this would have been 130, you can't raise 5 to some power and get exactly 130. So you need a backup plan. And the backup plan is called logarithms. So we're going to work problem number 1 again. And I'm going to show you my second technique, which is called convert to a logarithm. We're actually going to convert from an exponential to a logarithm. And when I taught this in class, I gave you a little poem to remember. Anybody remember the little poem? Bring the base down, switch the other two around. Remember that? So the 5 is the base. We're going to bring it down. Bring the base down. And what's the rest of it? Switch the other two around. So that's going to give me log base 5 of 125 equals 4x minus 7. And now you've got something you can button push. Right? With your nice Casio or your TI-36X Pro. Aaron, did you figure out how to get the log with the 2 squares on your calculator? Okay, you hit the log 3 times, right? And then you can put log 5, 125, and that works out to be 3. And do y'all see that puts me at the same step I was at a minute ago? Right? Where I can bring the 7 over, divide both sides by 4, and we get the same answer. So you'll get the same answer either way. It just depends on whether you want to use the method of common bases or whether you want to push buttons.
So on the logarithm method, would you use that one if you can't have a matched base?
Right.
That's when you don't have a matched base.
If you can't get the bases to match, logarithms are the only way out. Yeah. Okay, would y'all like to try another one? Another exponential. Okay, let's crank it up a notch too. Number 19. E negative 0.03 t equals 0.08. Again, is this an exponential or a logarithmic equation? Definitely exponential, right? Because it's got an exponent. And I don't see a log log anywhere. So, if we're going to consider the method of common bases, we would have to convert this into an e to some power. I don't see that happening, okay? So, on this problem, we're going to have to use the convert to a logarithm method, okay? So, what is the base? The e is the base, right? Because it has an exponent. And we're going to bring the base down. That's going to be log base e. And switch the other two around. And it's at this point that I'm going to ask you to remember something I taught previously. Does anybody remember? Okay, good. You do remember. Remember, log base e is really natural log. So log base e, that means ln. And I'm down to the last step. What do I need to do now to isolate the variable? Right. Divide both sides by negative 0.03. And at this point, you have something you can button push. So what is natural log of 0.08 divided by negative 0.03? Negative 8/3? Did it actually come out as a fraction like that? Let me see, Liz. What did you put? What? What? I thought you were about to tell me some mistake you figured out. Okay, so what mistake were you about to point out? No. No, that's not fine.
What?
Let's round that to the nearest 30 decimal places. I'm kidding. Let's round it to the nearest 100. 2 decimal places. Does anybody else agree with 84.19? Okay. Is there anybody that's not getting that outcome on the calculator? Let me know if you're pushing the buttons and not getting that so I can give you some calculator counseling. And do y'all have any other questions on that problem? Anybody? Okay, it's time to look for the Grand Master level problem. Yeah, the problem that even I don't really like because it's so freaking complicated. Let's do one. Number 28. Two to the x plus 1 equals 5 to the 2x. All right, so there's a couple of things that are different in this problem compared to the other ones we've done. First of all, did you notice that both sides have an exponent? We haven't seen that before yet, right? Only one side has had a power. Secondly, did you notice the 2 and the 5 cannot be made into a common base? So I can't make 2 to some power into a 5. So that makes this rather difficult to solve. So y'all write down what I do on the board, okay? And don't ask me any questions until the end. Just, I'll do my best, yeah. Are you ready? Okay, here's what we're going to do. Now, do you agree with me that whatever you do to one side, you have to do the other? So if I take the log of one side, I have to take the log of the other. Got it? Okay. Now the reason that I do that, now that this is in terms of logarithms, I have access to all of those properties I taught you. Y'all remember the 3 properties I taught you? Once I have this in terms of a logarithm, I can now access those properties. And one of those properties said if I have an exponent, where can it go? Y'all remember that? The power rule. If I'm taking the log of something with an exponent, that exponent can come down to the front. So the x plus 1 is going to get to come down to the front. And on the other side, so is the 2x. Okay, the next step, since the x plus 1 is a binomial, we're going to need to take the log 2 and distribute to get rid of those parentheses. This guy's going to need to distribute, so that's going to be x times log 2 plus log 2 equals x times 2 log 5. And I don't know if you noticed, but I took the 2 and the x and I switched places with them. Because 2 log 5, that's all number. So all of this is like the coefficient of x. All of that's number attached to the x. Okay, I forgot what I'm doing. Am I solving for x? I'm trying to solve for x, right? Okay, so now I've got an x over here and I've got an x over here. I need to get all my x's on the same side. Do you want to bring this guy over to this side? Or would you rather bring this guy over to this side? Which would you prefer?
Which is easier?
Okay, which is easier? Let's go ahead and take this guy over. And so that's going to give me log of 2 equals x times 2 log 5 minus x log 2. And now can you see that both of the terms that have an x are on the same side? And now do you notice that they do both have an x? And so we can use the 6-letter F word. Factor. Log of 2 equals x times 2 log 5 minus log 2. And I factored out the x. And now I'm to the last step. Now what can I divide both sides by? You have to divide by what's being multiplied by the x. 2 log 5 minus log 2. 2 log 5 minus log 2. I can divide both sides by all of that stuff. And so we're going to have x equals log of 2 divided by 2 log 5 minus log 2. And what, Liz, what did you say you wanted to do there? Cancel those? Yeah, that's illegal. You know why, though? And not because I said so. It's because this log here is one of the terms of the bottom. And remember, you can't cancel terms, but you can cancel factors. And I've seen people do this before. They'll go, oh, everybody has a log, and they cancel all the logs. And they're left with 2 over 2, 25 minus 2. And that's way illegal. Way illegal. I need this calculated to the nearest 100. I need to see who the real calculator ninjas are, okay? Who has a black belt in button pushing? 0.27? Oh, yeah. But I'm not going to put something like this on the test. But if I did, I'd ask for it. No, I covered this just so you could get a taste of how exciting this stuff can get. But I can test you over logs without killing you. Did anybody else get a 0.27? Yes? Yes? What'd you get? Okay, let's turn that around so you can see it and get clear. Yeah, that's not right at all. You needed to start with this guy right here. Because we got a fraction. And then you're going to put log 2 on top. Where's your log? Yeah, log 2. And then you've got to close your parentheses. And then move to the bottom. 2 log 5. Don't forget to close your parentheses. Minus log 2. There you go. Try that. Oh, snap. It is 0.27. Wow, we did all that work for 27 cents. All that work for 27 cents. You know what I want to do? I want to check and see if that's right. Yeah, we're going to check it. Guess how we're going to check it? We're going to come all the way back up here to the original problem, and we're going to plug in 0.27 for x. 0.27 plus 1. And 2 times 0.27. So with your calculator, I need you to calculate 2 raised to the 1.27 power. But because 0.27 plus 1 is 1.27, what is 2 to the 1.27 power?
2. Where do you want it rounded to? 2.41.
Okay. Now, I want you to do 5 raised to the 2 times 0.27 power.
2 again, so it's 2.38.
38. Anybody else agree with that? And do y'all see that those are, they're not equal, but are they approximately the same? Close. Okay, close enough for government work. Yeah. So do you think that these numbers would get closer to each other if I made the 0.27 go farther? The more accuracy I can make the 0.27, the more accurate, the closer these will get. Yes, with more decimal places. And the last thing we're going to do before we move away from this problem is we're going to go to Desmos. Because you know I can't go a day without Desmos. And we're going to graph, actually we're going to type in the equation and see if Desmos will just solve it. 2 to the x, what, plus 1 equals 5 to the 2x. Did y'all happen to see what all I did is I just typed in the exact equation, and what did Desmos do? Drew a line. What the? Where's that line? Well, it's somewhere between 0.274 and 0.275. So is that about 0.27? Yeah, and I don't know why it won't let me click on that line. It's not letting me click. That's freaking frustrating. Okay. You know what? I'm going to fix it. Let's say y equals that, and cut, and y equals paste. Bam! Ha-ha! Do you see what I did there? Okay. What I did is I said, let's let the left-hand side be one equation, and let's let the right-hand side be another equation. In other words, I made each side a separate equation. And can you see that those do cross at 0.274? So if I set those up as separate equations, I can actually click on the point of intersection, and the x-coordinate is my answer. I think maybe Desmos is faster than doing it by hand. Yeah. Yeah, you can't use Desmos on the test, though, of course. But what if you get out in the real world and you get a job and your boss comes in with an exponential equation and says, quick, I need you to solve this before noon. And then you're like, I got it. Let me go to Desmos real quick. No, that's like a checker at Walmart. That low-level job. Yeah, okay. No, never mind. Probably not. Does anybody have any questions about exponential equations? I covered two methods, right? Method of common bases and the more useful technique of converting to logarithms. And now what we're going to do is we're going to look at how do we solve log equations. Number 39. Number 39. We've got log base 2 of 10 plus 3x equals 5. Is it pretty obvious that that is a log equation? Okay? Now we're going to talk about only one technique for how to solve a log equation. And the technique that we're going to cover is called convert to exponential. You want to solve a log equation, you probably want to convert to exponential. And so that means that you're going to have to use my poem again. How does the poem go? Y'all need to freaking learn my poem. Y'all are not saying it right. It goes, bring the base down, switch the other two around. I didn't call you out. Me. It's all about me. Maybe I do need to start calling people out by name. All right, bring the base down, switch the other two around. And at this point, I'm going to need you to calculate 2 to the 5th power. What? 32. And I think 2 more steps and we're done. Move the 10 over, drops that down to 22. Divide by 3. And we get x is 22/3. Piece of cake. So do we need to do another easy problem like that, or do you want to crank it up a notch? Did you take your pills this morning? What one?
Another one like that.
Okay, another one like that. Okay, so let's do. I'm thinking about number 40. Log base 5, 8 minus 7x equals 3. Okay, so how many logs are there? One, right? There's only one log. And so if there's only one log, that means that we're primed and ready to convert to exponential. So we're going to bring the base down, switch the other two around. Why did I write a 5? Three, 8 minus 7x. Everybody see how that works? Bring the base down, switch the other two around. That converts logarithm to exponential. And then what is 5 to the third power? 125. And then 2 more steps and we're done. You want to move the 8? So what is 125 minus 8? And then divide both sides by? Man, I hope it divides nicely. It does? Oh, it doesn't? 117 divided by negative 7? Is what? Oh, it didn't divide at all. Oh well, we'll take that. Okay, so there's 2 baby problems. Now we're going to crank it up to a whole nother level, okay? Next problem we're going to do, number 41. Now, how many logs are there? Too many is the answer. There are too many logs. Somehow we're going to have to get those 2 logs to become 1. And do y'all remember those properties I taught you? Yes. So these logs have addition between them, and that indicates the product rule. So when I put these 2 logs together, their stuff is going to get times. That's using the product rule. Okay, so like the movie Highlander, there can be only one log. There can be only one log. And then I'm ready to do the poem. Uh-oh, I don't see a base. Aha. Remember that base is 10 if you don't see it. And so we're going to bring the base down, switch the other 2 around. Oh, and look what I did. You see what I did? I did the distributive property on the fly. Bring the base down, switch the other 2 around, and I did the distributive property on the fly. Did everybody see the x squared show up? Oh, so that makes this equation quadratic, which means I got to set it equal to? Man, this stuff is exciting. Yeah, so 10 to the 1 is 10. Moving it over makes minus 10. And then I'm really hoping that that will factor. Can you read the signs? Plus and minus, x and x. What did you say, Marlene? 9 and 10.
One thing and my mouth says something else. It's 1 and 10.
1 and 10.
I even wrote a 9. And I was thinking
10 times 1 is 10. 10 minus 1 is 9. And now we're going to set each factor equal to 0. And I think we're going to get two solutions. X equal -1, x equal positive 10. And I think only one of those is a good answer. I think, yeah, Aaron.
Sorry to backtrack, but could you explain how you gotta combine the log, the 2 logs together like 10?
Oh, if you go back to the very original problem, there's no base, so it's still understood to be 10 there. That's a log base 10. And if you go back to the product rule that I covered, addition turns into multiplication. So the 2 logs become 1, and the stuff here gets times. That's from the product rule. But it was log base 10 from the very beginning. Okay, so which answer is no good? Yeah, the -1 is trash. And the reason we know that is because if I take that -1 and plug it back into this x here, does that make log of a negative number? Do y'all see that? It would make log of a negative number, and that can never happen. Y'all might want to write this down. It's good stuff. You cannot take the log of a negative number. You cannot take the log of a negative number. So any solution that you check, if it makes you take the log of a negative number, that answer's no good. Okay, and if it's okay with y'all, I would like to do one more like that because I really like those problems. Hint, hint, if you know what I mean, okay? Those are really fun and exciting. So let's drop down to number 57. Log base 6 of x equals 1 minus log base 6 x minus 5. Okay, so is it obvious that this is another logarithmic equation? And how many logs are there? Too many. There are too many. So somehow we're going to have to get those 2 logs to become 1. And in order to do that, first of all, they have to be on the same side. Yeah, so the very first step, we're going to have to bring that log base 6, x minus 5, over to the other side. And it was negative, now it's positive. Okay, so now can I combine the 2 logs using which property? Yeah, product rule. Using the product rule, we know that addition turns into multiplication. The 2 logs become 1. And their stuff gets times. Okay, and now that we're down to only one log, can I now do the poem? Okay, so now we're going to bring the base down. And what does the 6 get for a power? 1. Bring the base down. Switch the other two around. Oh, and we're going to distribute on the fly. Doing the distributive property on the fly.
Sign doesn't change for that X because we moved it over.
Right. It's because we're moving it over because we're converting to exponential. It's not because we're moving it from one side of the equation to the other like when we move terms. Did everybody see the x squared show up? And so now this equation is quadratic, so I need to set it equal to 0. So 6 to the 1 is 6. That's coming over to make minus 6. And with any luck, that's going to factor. Can you read the signs?
Plus and minus and then 1 and 5.
Did I hear 1 and 5? Well, first of all, the numbers have to multiply to make 6.
Plus 1.
So is 6 times 1, 6. And is 6 minus 1, 5. And do y'all know why the 6 has to go with the minus and not the plus? Yeah, because the 5's negative, so the big number has to be negative. Okay, and then I'm going to set each factor equal to 0. And it looks like I'm going to get 2 answers. And I hope you didn't think that you heard me say x cannot be negative. That's not what I said. X can be negative. But when I plug it in, log cannot be negative. You can't take the log of a negative number. So do y'all understand? If you get a negative number down here, sometimes it will work. But when you plug it back in, if it makes the log of a negative number, that's when it doesn't work. And I've still got about, what is that, about 10 minutes until class is over, officially? Yeah, Maria. I didn't understand the question. Oh, okay. Let's play the what if game, okay? Oh, why did I put 2 F's? I don't know. I'm going to leave it with 2 F's. What if? So what if the original equation said log of 3 minus x and some more stuff, okay? Let's say that. And then let's say that one of our answers was x equal negative 2. So if you heard me say x can't be negative, then you're going to throw out this answer. But that's not what I said. I said when you plug it back in, it can't make this negative. So if I plug negative 2 back in here, that's going to be minus a negative, which makes it a positive, and 3 plus 2 is 6, and there's not a problem with that. Huh? What did I say? 6? I'm sorry. Been hanging around y'all too long. So, negative and a negative make a positive. 3 plus 2 is 5. And I can take the log of 5. There's not a problem with that. So do y'all see, in this case, the negative answer may be a good answer. Because this is not a violation here. But if later over here, if I see equals to log x, then we have a problem. Because now when I plug that in here, now it makes me take the log of a negative number, and now it's in violation. Do y'all understand the difference? Okay, if you plug it back in and it makes you take the log of a negative number, that's when it fails. Fantastic. Any other questions? All right, I'm going to shut that down.